Hi everybody, welcome to another video in course Algebra, section 8.1, sequence and summation notation. Sequence, an infinite sequence a sub n, we use the curly bracket a sub n to denote an infinite sequence, which is a function whose domain is a set of all positive integers, or natural numbers, if you will. The function values or terms of the sequence represented by a sub 1, a sub 2, a sub n, and so forth. Sequence whose domains consist only the first positive integers are called finite sequence. Sorry, that was a typo. Yeah, so there's it is finite sequence. Right. So different. So it is a function. Sequence is a function. For a function, we write f of x equal to x squared. But in the sequence, we will write a sub n equal to n squared. Right. The difference in the function is that we might have f of negative 1, which is 1, f of 1/2 is 1/4. However, in sequence we cannot have n cannot be anything but n have to be a natural numbers. So we start with a1. Of course, we could be a0, a sub 0 too, but we have a sub 1 equal to 1 square, a sub 2 equal to 2 square, and so on. We do not have a of 1/2. Right, so that's the difference, and that is the notation. Right, write the first 4 terms of the sequence. Now this is very easy. When n equal to 1, we have a sub 1 equal to 3 times 1 plus 4. That is 7. N equal to 2. A sub 2 equal to 3 times 2 plus 4. So that's 10. N equal to 3. A sub 3. 3 times 3 plus 4. 13. N equal to 4. A sub 4. 3 times 4 plus 4. 16. Right, so we could just type it as function. Instead of n, we use x. And we'll just go to the table and 1, 2, 3, and 4. Yeah. But we actually can type it as sequence. Hit mode. Go to and choose sequence. Right. Then y equal to, we said the minimum is 1, so n start from 1, and u sub n, we just said n squared. Right. And we can go to table. Sorry, not n squared. 3n plus 4. Yeah, we're talking about this example, not that. Not that. So 3n plus 4. So that button, if it is in function, it will give you x. If it is in sequence, it will give you n. And then second table. So this is the sequence. The first term is 7, second term is 10, third term is 13, and fourth term is 16. Right. Next we have this, pretty much the same thing. The first 4 terms, so n equal to 1 to n equal to 4. So put 1 in for n. So that gives us negative 1. 3 minus 1, 2. n equal to 2, a sub 2 negative 1 square 3 square minus 1 8 n equal to 3 a3 negative 1 cube 3 cube minus 1, so that's negative 1 over 26 n equal to 4 a sub 4 negative 1 to the 4th power 3 to the 4th minus 1, so that's 1 over 80. Right. Let's see a fraction. Negative 1. Once again, this is negative, not that. To the n. 3 to the n minus 1. Right. So we have those numbers. Right. If you want to see it, if it's fraction, it's very easy. Variables, y variable, function. Okay, sorry. Variable, y variable. So this is u, right? Just hit, this is where's this u? Okay, see above number 7 there's a little u second, so that, and if you want the first term, that is the first term change to fraction, right? Now if we want more than one term, second, number 7, so that u, and we go from the first 4 term, so n equal to 1, 2, 3, and 4. And that's what we have. Convert this to fraction. So that's what we have. The curly bracket here is the set of numbers evaluated from n equal to 1, 2, 3, and 4. So that's what we have. Right. Next, recursive formula. Recursive formula is the formula which defines the n term as the function of previous terms. Right. Now look at this. For the first 4 terms, if a1 is 5 and a sub n equal to 3 times 8 and minus 1 plus 2. So we know the first term is 5, right? So the first 4 terms, so we need to start with a sub 2. So n equal to 2, we're going to put 2 here and here. It will be 3. 2 minus 1 is a1 plus 2. So 3, a1 is 5 plus 2. So that gives us 17. a3, put 3 in for n. A2 plus 2. A2 is going to be 17. Plus 2, that's 51, 53. A4, 3 times a, 4 minus 1 plus 2. A3 plus 2. A2 is 53. So that 159 plus 2 is 161. Right. We can also use the calculator for recursive formula. So n greater than or equal to 2, so it's 5. A1 is 5, so we could say n minimum, we start at 1, so u of 1 is 5, right? Now the recursion, we're going to have 3 n, and we say u of n minus 1 plus 2. Right? If we do that, there may be a problem because of no, it should be fine. All right. So we have 5, 17, 53, 161. Yeah, so that's fine. Once again, the minimum is 1, and so the first term is equal to that, and then we just going to write in that form. Right. Sorry, I make a mistake in the calculation on the calculator, so I have to recall again. So if A1 is 1, A2 is 2, so A3 we'll put 3 here, 3 here, and 3 here. So that's 2, A2 plus A1, and that's what we have. N is equal to 4, so we have 4, 4 minus 1, 4 minus 2, so 3 and 2, and 5. A5 is 4 and 3, so A6 is A5 plus A4. So each one is equal to the sum of the previous two number. Right. So how do we enter that in? We'll try again. Right, so we do have u of n minus 1 plus u of n minus 2. Right, the minimum, we have to enter 2 and 1. That look backward, but again the minimum is 1 and then 2. We have to enter it like that. So we have 1, 2, 3, 5, and 8. Right, I said this for this kind of problem, we just go ahead and do it by hand. Right, next, write the recursive formula for 2, negative 4, 8, negative 16, and 32. So what we see here is, we know the first term is 2, so let's start with that. Now, to get from the first to the second, we multiply by negative 2, multiply by negative 2, and to get to the next one. So, in that case, we say whatever that term is equal to the previous term times negative 2. Negative 2 times a sub n minus 1. And this is n greater than or equal to 1. If we put 1 here, 1 minus 1 is 0. We don't have that, so we have to be 2. So when we put 2 here and 2 here, 2 minus 1 is 1, so we start from that term, A1. So whenever we write this condition, make sure we have to put it in and equal to the initial term there. Right, this one, how do we go from this one term to the next? Well, that's easy. This is plus 3. So just plus 3 every time. So we start with the first term is 2. And this term is equal to the previous term plus 3, and then we can say n is greater than equal to, if we put 1 in here, it will have a of 0, which we don't have. But if we put 2, 2 minus 1 is 1, which we do know, so it's good, n equal to 2. Right, so that is the recursion formula. Next, we have factorial. Definition: if n is a positive integers, the notation n exclamation point, and we read n factorial is the product of all positive integers from n to 1. So we multiply from n minus 1 all the way back to 1. And we also define 0 factorial equal to 1. So for example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1, which is 120. Sorry. Yeah, 120. In a calculator, we're going to hit 5 first, and then math, go to probability, option number 4. Yeah. And factorial can be written as a recursion formula. 1 factorial is 1. N factorial is equal to n times n minus 1 factorial. Right, so to get to the next factorial, we just multiply by the number. Right, so what is 6 factorial? So we can write as 6 factorial is 6 times 5, 4, 3, 2, and 1. Now, 5, 2, 1 is 5 factorial. So we can say this is equal to 6 times 5 factorial, right? Which is equal to 6 times 1, 20, which is 720. Right. Now, if you write, once again, 6 factorial is 6, 5, 4, 3, 2, 1. If we just say 4, 3, 2, 1 is 4 factorial. So we can say 6 factorial is 6 times 5 times 4 factorial. So actually we used the factorial is the clever way we say it. We start from that number, 6 factorial, we start from that. Whenever we feel like we want to stop, just put the exclamation point. That's when we stop there, right? Now with that, help us to simplify this expression, 10 factorial. We might say 10 times 9 times 8, 7, 6, 5, 4, and so on, all the way back to 1. But if we want to stop, exclamation point. So factorial here means it goes from 8 all the way back to 1. We just don't want to write all the way back to 1. Right? So as you see, and then we can cancel nicely a factorial, 10 times 9, that is 90. Right, same thing here. A factorial, we can start from 8, 7, 6, and then we will stop at 5 because there is a 5 factorial at the bottom. Which we cancel this out. And so 8 times 7 times 6, and then 3 factorial, 3, 2, 1. By the way, 3 times 2 is 6. So we just have 8 times 7, 56. Right, so factorial, we start from that number and then 1 less all the way to wherever we want to stop. Just put the exclamation point. That will take care of it. Next, write the first 4 terms for this expression. Well, this is what we see before. That should be easy. N equal to 1, so we have A1, 2 to the first, 1 minus 1 factorial. So give us 2 over 0 factorial. 0 factorial by definition is 1. A sub 2. Put 2 in for n, and 2 minus 1 factorial. So that is 4. 1 factorial is 1. 3. 2 to the third power. 3 minus 1 factorial. So that 8 over 2 factorial. 2 factorial is 2. So it's 4. A sub 4. 2 to the fourth power. 4 minus 1 factorial. So that's 16. 3 factorial. 3 factorial is 6. Reduced by 2. right? So that fraction 2 to the n minus 1 factorial math probability option number 4, and let's see the sequence, right? 2 4 4, and that is a over 3. Right, this one a sub 1, put 1 in for n, 1 factorial 2 to the first power, so we have negative 1 factorial is 1, 2 to the first is 2. Now a sub 2, negative 1 square 2 factorial 2 to the second, negative 1 square is 1, so just 1, 2 factorial is 2, 2 square is 4, 1 half, a to the third, a sub 3, sorry, negative 1 cube 3 factorial over 2 cube, negative 1 to the third is negative 3 factorial is 6, 2 to the third power is 8, reduce, give us negative 3 over 4, a sub 4, negative 1 to the fourth power 4 factorial over 2 to the fourth, negative 1 to the fourth power, that's 1 because an even power, so we have an even number of negative sign, so just 1, 4 factorial is 1 times 2 times 3 times 4, 24 over 16, reduced by 8 3 halves, right? Negative 1 to the n power, and then the fraction let's try this again, negative 1 to the n power times fraction n factorial over 2 to the n. Alright, negative 1 half, negative 3 over 4, and 3 over 2. Right, just one thing though, when we see the negative 1 raised to the n power, the signs alternating negative, positive, negative, and positive. So that divides negative 1 to the n, or negative 1 to the n plus 1, or negative 1 to the n minus 1. Those divides will change the sign. That make the term alternating signs. Right, next we have the summation notation. Summation notation is if we sum the first n terms, it's going to be this. So pretty much we will substitute the lower limit. This is called the lower limit. This is the upper limit. So we substitute the lower limit into the term and then increase by 1 until we hit the upper limit. And we just add all of them up. So for this one, pretty much what we'll do, start from the lower limit is 1, put 1 in there, 1 square plus 1, right? Then increase that values by 1. So original I is equal to 1, now I is equal to 2. And then I equal to 3. I equal to 4. and I equal to 5. Right, add all of them up. This is 2, 4, 5, 9, 1, that's 10, 16, and 1, 17, 25, and 1, 26. Just add all of them up. 7, 17, 34, 26, that's 70. Sorry, 34, that's 60. Right. I certainly, of course, check with the calculator. If your calculator TI-84 or newer, hit math and go down to option 0. And then what we see is what we get. Instead of use x, we just use n. Instead of use I, we use n equal to 1 to 5. And we have n squared plus 1. Yeah, we just change n to I to n. So, yeah. So substitute the lower limit and then increase that every time until we have the upper limit. Right, this one we don't have, the problem don't start from 1, doesn't start from 1, which is fine. We're just going to put the lower limit. Now we're going to put, increase that k by 1. Increase that k by 1. Increase that k by 1. Right, so that negative 2 to the 4 power 16 minus 5, 11. Of course, I'm going to check with the calculator. Just try to do this by hand. Negative 2 to the 5th, that's negative 32 minus 5, negative 37. Negative 2 to the 6th, that's 64 minus 5, 59. And negative 2 to 7, 128 minus 5, minus 128, sorry, minus 5, 133. So 11 and 59, that's 70. And minus 170. So minus 100. I see if it works. Right, math, option 0. Use n equal to 4 to 7. Negative 2 to the n minus 5. Right, that's good. Right. So once again, substitute the lower limit and then increase that by 1 until we have the upper limit. So that's easy. Now how do we write the problem in reverse? Meaning that when we have the summation, how do we write that in the summation notation, right? So for this one, when we look at the term, the common thing is something raised to the 3rd power, right? 1 cube, 2 cube, and all the way to 7. And then if we're going to say k, then k will go from 1 to 7. And that's pretty much it. Of course, if you don't want that, remember we start with something cube. And let's say we don't want to start with k. If we choose k plus 1, let's say we also say that, or minus 1, or whatever we want. Let's say k plus 1. Right, so we have to start something that we have the 1 So in that case, k will start from 0, because when we put 0 in the first term, it's going to be 1. 0 plus 1, so it's 1 cube. And it's go to the last one is 7, so this equal to 7 when k equal to 6. So potentially we can just use that or that, either way. Still, put in the lower limit, increase by 1 until we have the upper limit. Put in 0, we have 1 cube, on the way to 6 plus 1, so 7 cube. So that's what we have. So the trick here is we have to see the pattern of the summation when we try to put in summation notation. So how is difficult to see is this pattern. So let's say all of them have fractions, so we try to manufacture a fraction out of it. Alright. Now that doesn't come up with the pattern. Yeah, we have the fraction. So if we want to, yeah, that's what we have. It's a fraction. There's 1 on the top. So those are the common that we see for every single term. That's what we have. Now we don't see really what is the pattern. The pattern is the number that increase by 1 every time. So now instead of writing like that, let's say if we want to write as 1 over something, I'll take care of that later. 1 over 3 to the first, 3 square all the way to 3 to the n minus 1. Now with that we can see that this is to the 0 power. 3 to 0 power is 1. Now we see the pattern, which start from 0 to n minus 1. But usually we say k equal to 0. We don't really need to say k equal to for the upper limit. Alright, so to write as a summation notation, we have to see the pattern, what is common on all of them. And there is something that increases by 1 every time, and that will be the index. The index of the summation. The k here is called the index. Anyway, I've stopped section 8.1 here. Thank you for watching, and see you in another video in Algebra.